I think I am right now. Can anyone confirm if audio and everything is fine? I will probably wait for 2 minutes before starting this show so that probably people can join in. I think the contest was initially scheduled for 2.5 hours. That's how I had my stream like scheduled later. But and like it was quite funny. Like I don't know why my C gets a W, and like I was able to solve E1 and E2, and probably I did not have enough time to spend on B. So like obviously I will discuss A, B, E1, E2. I will discuss what I was doing on C, and I don't know why it's a W. And probably for D, like I can probably take a look at some participant solution and try to explain what they are doing. So like that would be the agenda for the stream. So let's wait for 2 minutes and then we will start. So I am not sure. Like I am yet to take a look at streaming and see what people are doing. Okay, see. Probably someone wrote a comment. We learn RNA structure. So probably people in the chat, like how many problems were you guys able to solve to give me a rough estimate of where most people are stuck? For E, like probably my solution is like this is something, let's try it, and that got an AC. So right now like I don't have a proof why that particular thing works on me. Okay, 1 more minute and then I will produce. So probably I think let's start now. It says you are given three integers x, c, y, c, and k. You need to find k distinct integer points having integer coordinate on 2D coordinate plane such that their center is x, c, y, c, and x, I, y, I are between -1 in 9 and up to 1 in 9 for all I from 1 to 2. It can be proven that at least one set of k distinct positive integer always satisfies this condition. So and like the formula for center is also given to us. This would be the formula. So like the first idea I had was 1 second. Okay, like the main idea I had was like we know that would be equal to sum of x coordinate by k, right? So like my main idea over here was, let's pick one point equal to k into xc, and for all the remaining points pick them in such a way that their sum is 0. So that now when you look at sum of all the coordinates, like the main idea was like basically just pick k xc and k yc as the first point, one of the point, and pick remaining points in such a way that sum of their x coordinate and sum of their y coordinate is 0. And the way we can do is like we know that k is up to 1000 and y is up x and y is up to 100, right? So this point would be between 10 to the power 5 and minus 10 to the power 5. So the idea is for remaining point, like we can start taking minus 10 to the power 6, 10 to the power 6, minus 10 to the power 6, minus 1, plus 10 to the power 6, plus 1. And like these points are always greater than whatever the first point you have chosen. Minus 10 to the power 6, minus 2, plus 10 to the power 6, plus 2. And we can keep x and y coordinate like this. And like you see, this comes in pairs. Probably it may happen that you have one remaining coordinate. Like for example, let's say you have to pick 8 points. Then the idea would be like we would pick first point as this so that the center is balanced. Like I will probably show my code. I won't code directly, but for this problem I will show my code. And then we can take second and third point as x and y coordinate as these points. Third and fourth and fifth point would be this. Fifth and sixth, the idea would be to take this. But the idea is like for the 8 point, we would take 10 to the power 6 plus 3 and minus 10 to the power 6 minus 3 and 10 to the power 6 plus 3. The idea is like we can take only one point here, which would be the 8 point. So we can probably just merge these 2 points to get a 7 point. And like that was my idea here. And let me probably show you my code. Take xc, yc and k as input. Put the first point as k times xc and k times yc. Now start from like 10 to the power 6 or something, the number which is more than these coordinates. And then for all a less than, like as long as you have size less than k, if you can add 2 more points, then add these 2 points, j comma 0 minus j comma 0, 2 points on x-axis. And if you can only 1 point, then the idea would be like just combine, like new point we want to add would be so here we merge j minus 1 so that you just add one more point and sum of x coordinates still remains 0 apart, ignoring the first one. And at last print all the points. Like this was one way to solve this problem. Any questions on this one or any other creative idea you guys had for this problem? And like That was the idea here. You are given a permutation P of length n. Find a permutation Q of length n that minimizes the number of pairs such that the subarray sums is always like, if you look at two subarrays, yeah, like you can also make x all 0 except the one which would be xc into k, and then you can insert y equal to 0. Y 0, 0, 1, 1, minus 1, 1, 2, 2, minus 2 did not work in here. Like the problem is, it also says all the k points should be different. It may happen that if you are choosing 0, 0, 1, 1, etc., you may have the same coordinate as, like you can have two different coordinates which have same value. Because xc and yc, let's say that is 0, 0, then that may be a problem there. Or xc, yc is like, let's say 3, 3, then in your code you may print 3, 3 there. And like there are different creative ideas. People had was probably to add just one xc, xc minus 1, and xc plus 1, and so on. Yeah. Yeah, like some people also did it this way. Like they printed this points xc, yc, xc plus 1, yc, xc plus 2, yc, and so on. And this way print k minus 1 points like this. And for the k point, you keep yc as it is, and like you subtract xc minus sum of numbers from 1 up to k minus 1. Yeah, that is also a nice creative approach, by the way. So the idea is like you take xc as an offset, and like you whatever extra delta in one of the point you add, you just remove it from all the points. And like that can be another creative idea. Great. So probably moving on to the next problem. It says you are given a permutation P of length n. Find a permutation Q of length n that minimizes the number of pairs I and j such that sum of values from I to j in P is equal to Q to j in P. So like here also probably some people might have different idea. What I did here was, for like set Qi equal to Pi plus 1 if Pi is less than n, and 1 if Pi equal to n. Okay, did not understand the problem. Okay, I can show you like what the problem statement is asking you to solve. Let's pick some permutation. Let's say 1, 2, 3, 4, 5 is one of the permutation you have. Or let's say 1, 2, 3. And let's say we also have QS 2, 1, and 3. Now like let's look at different subarrays from both of the permutation. This can be one subarray, but it does not have equal sum, right? Here like sum of every element in this element in green is 1, every element in Q is 2. If you look at this subarray, sum of every element in this is 2, sum of every element is this is 1. So like we don't really need this. And while you look at this subarray, sum of every element in P in this part is 3, sum of every element in Q is part is 3. So this is one valid permutation we have. Now let's look at a bit further. Let's look at these two elements. Sum of every element of P here is 3, sum of every element of Q is also 3. So it says like this is also one valid pair over here. Like let's probably look at this array as well. Sum of every element in Pu in this array would be 5. In Q it's 4. So that's fine. Like it's not a value. And like if you look at this complete part, sum of every element in the complete part is 6 in both the arrays. So overall we got 3 parts with equal sum in both. in both. So the idea is the problem statement gives you an array P. You should find one Q such that this number when you calculate after looking at P and Q is as small as possible. And like that is the idea we had over here. So any questions on the problem statement before I jump on to the solution? And looks like some people did few other things as well. And I can probably share the chat solutions as well. Okay, yeah. So what I did was I said explain one more. Okay, sure. The problem statement gives you one permutation P, which is an input, and it asks us you to print a new permutation Q such that some function you get over there, the count over there is one more example. Yeah, sure. Can you give me two permutations of length 4? Okay, permutation means all the elements should be between 1 to 4. 4, 1, 3, 2. Let's say this is P. Also give me some Q. 2, 3, 1, 4. Now let's inspect some of the arrays here. Like let's look at this array in both of them. Sum for P is 5. Sum for Q is also 5. So let's count arrays like this where you pick one left index, one right index. Look at sum of all the elements in P, sum of all the elements in P, and that sum is equal. So here like 4, 1, 2, 3 is one such pair. 3, 1, 3, 1 is another such pair. And do you see more such pairs? Like single element does not matches anywhere. Length 2 is this, 2 is this. This is also available. This, like the subarray in green, also had same sum for both P and Q. Let's look at length 3. This does not work. This does not work. And like if you look at length 4, this complete array also has same sum. Yeah. So like we got 4 pairs with same sum in P and Q. Those pairs are 1, 2, L, R if I say, 2, 3, 3, 4, and 1, 4. So if this is given to you in problem statement P, if you print this as Q, then the number of sub arrays with equal sum you would get count would be 4. And problem statement says find such a pair where this count is minimum possible. Like, and what I am saying is like I will find one pair where this count would only be 1. So in this case, like if P given to you is 4, 1, 3, 2, if you print 2, 3, 1, 4, you would get 4 as the pairs where the sum is equal. And that would be wrong because I can find one another Q where this count would be only 1. And that is the minimum possible because like in a permutation sum of all the elements would be sum of first n elements, and it does not matter how you arrange Q, you would get sum of all the elements when you take entire P, entire Q. So minimum 1 is minimum possible, and I am saying like I can say one way using which you can get such one pair. So any questions on the problem statement before I jump onto the solution I had for this problem? Yeah, I can show the code I have written in the context. Link on the Codeforces is not working. Let me check. Okay, I think I have updated. Yeah, so I will probably jump on further. So my idea was look at P for QI. I will set it to PI plus 1 if PI is less than n and 1 if PI equal to n. First thing first, you can see like all the elements from 1 to n will appear only once in this queue, right? Because this will print all the numbers from 2 to n, and here I am printing 1. And like question is, why will count of equal sum subarray would is 1? That's the important question we have, right? My claim is if I set qi equal to 1, like qi like this, then only sum of complete p and complete q would be equal. Any other subarray you take will not have equal sum. Like I will jump onto the solution for that, but can you try to prove it why this would be the case if I choose qi like this? Like let me take one example. Like let's just take the example from the code. 4 1 3 2 was the p given to us, and the q I would be printing here would be, if it's 4 print 1, for 1 print 2, for 3 print 4, for 2 print 3. Like definitely sum of everything is equal. Otherwise if you take any part here the sum at the top is 4 but sum at the bottom is 6. Or if you take this, then here sum as top is 5, sum as bottom is just 3. And this is definitely not equal. Like, and you can verify in this permutation, if you take anything not equal to the complete array, sum will not be equal. Because the sum of q will always be greater than to corresponding sum in p. That holds true if your part does not contain 1. Like let's probably look at di, which is sum of pi minus qi. Like equal sum from L to R means sum of differences for each element from L to R should be 0, right? If you create a new array di, where di is equal to pi minus qi, then sum of all the elements from L to R equal to 0 means for all L to R to I, that sum of di should be 0. Like, can you see why? Because we can write sum of L to R as sum of pi equal to sum of qi. If you move this on the left side, this becomes sum of pi minus qi equal to 0 for all I R. And now if you replace it with di, this becomes sum of di equal to 0 LIR. And now like in my updated array, you see wherever pi equal to n, di is n minus 1 because qi would be 1. Otherwise, di is equal to minus 1. Yeah, right shift will probably work, and you can probably try to prove it. I just ignored that. Like right shift also you can prove it like why the element will work. And now if you look at any L2R, any length array with length less than n, if it contains 1, yeah, like, why is qi 1 when pi equal to n? Because like that's how I define, like I want all the elements in q from 1 to n only. I cannot print n plus 1 in q because I want it to be a permutation. If it contains some pi equal to n, then like I would subtract length minus 1 times and add n minus 1 time, and you can verify this is greater than 0. And if it does not contain pi equal to n, then you will probably do minus length times, which would be 0, less than 0, and that's the idea. Like any questions on this problem before I jump onto the C? I can share what I did in C, which probably got some W somewhere, I don't know why. Then I can probably take a look at some of the participant solution to see like what they were doing. And I will skip D because like I haven't really grasped much on the D, like what should be done there. And after C, I will jump on to E1 and E2. No, array equal to n minus array does not work on B. Let's look at this. You will print 4, 1, 3, 2. This has same sum, this has same sum. That was one idea I had when I was trying to. Okay, jumping onto the C. Says perform operations to maximize score. You are given an array A of length n and an integer k. You are also given a binary array B of length n. You can perform the following operation at most k times. Select an index I such that bi equal to 1 and set ai equal to ai plus 1, that is increase ai by 1. No, just reversing first and second element will also not work, like the same reason. Your score is defined as maximum you can get for all where ai plus median of ci, where ci is an array of n minus 1 by deleting ai from the array. Find the maximum score that you can achieve if you perform operations optimally. And it says for an arbitrary p, median is defined like this, like basically the middlemost element. In case the length is even, take the smaller median. I will probably take one working example here. Probably any working sample you want me to take for this problem, like any sample which you want me to explain. Like probably let's take this one. 4 tests is 1, 2, 3, 4. Yeah, okay, I will probably take 4 tests. It says A7, 5, 2, 5, 4. And B is 0, 0, 1, 0, 1. And like you can do operations 4 times. So like what you can do is, like for example, in one operation you take this element where bi equal to change 1 and change this 2 to 3, and then let's say you also change this 4 to 5. That can be another operation, and in the next operation you can change this 3 to 4 and then you change it from 5 to 6. Let's say these are the sequence of operations we are doing here. Like we change, like we cannot change any element where b is equal to 0. So what I am doing is I am changing this, adding 2 times to the 2 and 2 times to the 4. So the new array I am getting over here would be 7, 5, 4, 5, 6. Like let's say this is the array I got after some operations. I am not claiming this is the optimal. It may happen that the better answer exists for some other sequence of operations. But to explain the problem statement, this is what I did. Now it says for each I, delete that element. So for example, if I delete I equal to 1, the remaining array would be 5, 4, 5 and 6. The median here would be 5. Because like the sorted array would look like this, and like this is the second element, like these 5 and these 5 are the middle element, you should take the smaller median. Let's also find median if you remove the second element. The remaining array would be 7, 4, 5 and 6. Let's sort this array and let's look at the second element over here, that is also 5. Let's also look at I equal to 3. Here we will delete this 4 and look at the remaining array, 7, 5, 5, 6. Let's sort this array. The sorted array becomes like this, and the median here is also 5. Let's remove the fourth element as well. The sorted array becomes 7, 5, 4, 6. Sorted array looks like this, and the median here is the second element in the sorted array, which is again 5. Coincidentally, every time we are getting median is 5. That may not happen in the original example. Let's look I equal to 5 element. What is the array after we delete this element? The remaining element becomes 7, 5, 4, 5. Let's sort this array and look at the second element, 4, 5, 5, 7. The median here is also 5. So what we did was, for each element I, once you have finalized what operations you are going to do, find like how many, like once you fix how many operations you are going to do, find what would be the median after you remove that index. Now for this median, add A1 to it, the element which you have removed, which in this case is 12. For this also add the element which you have removed, which would be 10. For this element also add the element which you have removed, which would be 9, 5 plus 4. Here like add the element which you have removed, it would again be 10, fourth element was 5. Here add the element which you have removed, 5 plus 6 would be 11. So now you have got some bunch of values, 12, 10, 9, 8, 11. And then it says find the one which has maximum value. In this case, this is the 12 value here. So 12 is what we can get maximum out of if we do like the operations which I have mentioned before. 12 may not be optimal here. Like it says the optimal is 13 here. So like we may have to do some other sequence of operations. Probably instead of doing it like this, for the fourth time, we should have increased this element to 7. Or probably like that would have given, and probably even instead of changing like 2, let's also change this as 4 times, increase this 4 times. So the new array we would get would be 7, 5, 2, 5, 8. And now the idea would be to seven, 5, 2, 5, 8. Yeah, like, and what should we delete? It's here. Here, let's delete this 8. The remaining part would be 7, 5, 2, 5. Sorted part would become 2, 5, 5, 8. The median will come out to be 5. Plus if you add the original element, which would be 8. And overall you would get 13. and this is the answer. It claims like this is the maximum possible. So like you understood what the problem statement is doing over here and what it is asking us to do. Any questions on the problem statement before we jump to the solution on how to solve it? Yeah, I will first jump on to my approach, and not definitely not sure why it was giving me W there. Okay, so my idea was we have some array A. Let's forget. No, it was not saying sum up to J starting from I. Yeah, like that is what the problem statement is saying. Sum up to J starting from I is equal to sum of all the elements from I to J. Number of indexes I and J which is equal in both P and Q. And my claim was you can change it in such a way that only if you take complete array, then only it will be equal for any other element with that is not equal. So my idea in the contest was, let's first forget that we have to delete some element. So like let's say we have this as an array, some array. Let's sort A as well. Sorted A. And like probably let's look at something here. Let's just take the previous example only. 2, 1, 4, 1, 5, 0, 5, 0, 7, 0. I have 4 operations. What is the maximum median I can get for this array? Binary, I was doing binary search here. The idea is, let's say if we have 5 elements, and then the third index would be median, right? So if we want to check if we can get median greater than equal to mid, what we want is after our operations, at least 3 elements should be greater than equal to mid. Yeah, for 4 elements it would be second element. I am just taking some example here. Like this does not solve my problem. What I am saying is, like let's first forget the original problem. Let's say you have this as an A and B, and you can do plus K on some of the elements. What is the maximum median you can get? The idea is like median would be the third element. So we have to find, we can binary search on the element and count like how many elements we can get greater than equal to mid in the array. If I can get at least 3 elements greater than equal to mid, then I can say my median is definitely more than mid. And if I cannot get 3 elements greater than equal to mid, then I would say my median cannot be more than mid. So like that was my idea, and for that I was using segment tree. Like now when I want to count how many elements I can get greater than equal to mid, or like can I get, like no, look at it other way. Question is, can I get 3 elements greater than equal to mid using at max k operations. The idea would be like, let's look at the sorted array. Some part would be greater than or equal to mid. Let's directly count these arrays because we don't have to do anything over here. Like let's say this count is 2 and I need 3 elements greater than or equal to mid. Now find one element which has bi equal to 1 and less than mid. Or probably let's say, or let me just take live example 3, 4, 9, 11, and I have mid equal to 10. 1, 0, 1, 0, 0. So I first count how many elements are greater than or equal to mid, which is for 10. Only one element is greater than or equal to mid. And I want 3 elements greater than or equal to 10, right? So I will have to choose the largest two and push these 2 up to 10 and 4 up to 10 as well. So like I was again doing one more binary search here to find what is the smallest index up to which I can find 2 elements. And then sum of these 2 and 4, like it would be 6. So 2 into 10 minus 16, I need 14 operations. If my starting array is 2, 3, 4, 9, 11 and one is with 2 and one is with 4. So to get median greater than or equal to 10, I will need at least 14 operations. And because I had only 4, so I said 10 is impossible. And like that is my reasoning was. And that is what I was trying to do in the contest. And to solve it for all I from 1 to n, what I did was, I put all the elements in the segmental whatever data structure I was maintaining. For each index I, remove I, first do this thing. Next time for all I equal to 0 to n minus 1. Remove ith index, find max median, and add I again. And here like I was just checking, I was also checking if bi is 1, just find max median with k equal to 0 and do ai plus equal to k. And if bi equal to 0, then find median with k operations. Like that is what I was doing. And unfortunately it was failing. Like I can probably briefly show the code here. And like my implementation was also messier and I don't know like where I did wrong, something wrong. And then k is input, all the elements as input. Then some coordinate compression etc. was there. Then an encoder segment tree which maintains 3 values. Sum of all the elements where ai is 1. Count of all the elements where bi, sum of all the elements where bi is 1. Count of all the elements where bi is 1 and count of all the elements where ci is equal to 0. And this update function which basically takes an index and removes that index from there. V equal to 1 means add, V equal to 0 means remove. Find the sorted array like in the coordinate compression with median, find the index where it is. If that index has bi1, then add these 2 values, otherwise add it here. And then set that value at that index again, lot of things here. Then for each index, remove that index from the array, at last update it. If bi is 1, then take current element from what is the maximum median you can get by doing k operations. Otherwise, you just add k to ai plus 1 and maximum median you get with 0 operations. And to get median with k operations, I was doing a binary search. I see where the problem is. This should be 3. Like there is an potential interval here. And then for the mid, like I was counting how many elements are greater than mid here. Using segmentary count how many elements with 0 and 1 there. Like this is the count of element I need greater than mid. If it's already 2, then that's fine. And otherwise, now like I was doing one more binary search on segmentary again to find from what coordinate etc. over there, and like a lot messier. But yeah, I think like if system testing fails, I will probably submit my code here. And then I will probably show the Neil's code what Neil did, and his solution was definitely easier. So what Neil is doing is one AI test evaluate function which takes an array A, returns its median. Like what it's doing is like it takes the highest element as the element it wants to remove, and for the remaining part it takes the remaining median. So one thing he did was found the maximum element where like we have bi equal to 1. Then he added plus k in that element and found what can be the maximum answer we can get. Like basically find the maximum index element which has maximum index and also has bi equal to 1. And like one of his logic was remove the maximum element, find median of the remaining part, and then add it back. That was one thing he is doing here. And if all of the bi's are 0, he was directly printing that element. Otherwise, this one algorithm was at maximum index where bi is 1, add plus k. Using the same algorithm, find the median you can get, undo the operation, and that is one of the answers here. And then he found overall maximum. If overall maximum also had 1, then you don't need to do anything over here. You added k to the maximum element and that's fine. Otherwise, he has this need count, like how many elements he need greater than equal to median there. One possible function which looks at like how many operations we need if we want to make median greater than equal to median. And these are the costs here. Like what he is doing is like his idea is he will remove the overall maximum and try to get maximum median he can get for all the remaining elements. So ignoring the overall maximum index, if vi is 1, he adds the cost to make element greater than equal to minimum over there for ai. And otherwise, if current element is also greater than equal to mid, he also adds a cost greater than equal to 0. And if he cannot increase more than the elements he needs, he was directly returning false. Otherwise, he was sorting all the minimum counts there, and he was looking at like first need number of extra costs he need to make element here. So this is in n log n. This binary search also takes one log factor there, and he is like his second best answer. Like he had two answers, 2 ways he was finding an answer. One is you just look at the original array. You are not doing like you found maximum index where bi is 1. And add plus k there, and now look at the sort all the array, take maximum element. Like his idea to like once you have fixed a, his idea is he will remove the maximum, find the median of the remaining part, and then he will add both of them. So one thing he is doing plus k at the maximum element where bi is 1. That is one of his answer, and his another answer is binary search on the maximum median once you have removed the overall maximum part, and for that he is doing this operation there. And like this is what he is doing, and I think I'm confident about, yeah. This was my first submission. Where is my binary search? Implementation is definitely a messy, like, because I was trying to find maximum for each index what you can get after removing that index. And the smart thing that Neil did was you have to just look at two values, one element where what is overall maximum of the array, and one element where bi is the maximum of all the array. So like this was the idea. Like my implementation is definitely massive because I was trying to look at what is the maximum median we can get for each element. So any questions on problems? I will skip D because I haven't really spent a lot of time on D. I will move on to E1 and E2 after we are done with D. Yeah, definitely a lot of time, but so yeah, like the problem here was like I took so like you should be careful with what bounds you keep for your binary search. Like what I did was I took large for the median binary search very large, and I was getting a long in overflow here, and that's how we are. Any questions on this problem before we move on to E1? Okay, let's solve problem E1 first. Like, don't ask me the time complexity for me because I don't really have some proof, etc. Why the solution should be within time limit. Just that I had an example. It says you are given an array A and like basically an array A of n integers. You create an element of, or probably like let me give some better way to do it. Let's take this as an array. 1, 2, 3, 2, 1. This is a. Let's also keep their index here. It should be 1, 2, 3, 4, 5. The idea is you will look at two consecutive parts and merge them. Like I am briefly summarizing the easier way, like problem statement does. Like let's look at any two consecutive parts. Like let's say we take this. The idea is the larger element will eat the smaller element. Look at it like this, like we have different fishes over here. Each of them has some different strength. And the idea is you have a choice to have a fight between any two fish you want. Like for example, I want a fight between these two. And the idea is like here now this larger fish will eat the smaller fish here. And after you do this, your updated fishes sizes becomes 1, 2, 5, 1. And their index is still 1, 2, 3, 5. Now you can have a fight between these two as well. And the idea is like the larger one will eat the smaller one. So we don't no longer have this fish. New fishes we have would be have these much strength and their index would be 2, 3, 5. Now we can have a fight between these two. Again, larger will eat the smaller one. Updated array fishes size would be 2 and 6, and their index would be 3 and 5. Now, if we have a fight between these two, the final fish we would get have a strength 9 and it would be of index 3. So, like, if you see, like, if this is one way we are fighting people over here, index 3 can be a winner. And like in case two fishes have equal energy, you have a choice to decide which one would be the winner. So like let's look at another way as well. 1, 2, 3, 2, 1. Index here would be 1, 2, 3, 4, 5. Let's say in the first go we have a fight between these two. This will no longer be there and its energy will become 3. The updated strength we would have would be 3. Now let's say we have a fight between these two. And it's our choice to decide who would be the winner because both of them have equal strength. Let's say I want this to lose and this fish to have 6 energy. Let's say now we have a fight between these two and this one will win because it has more energy or more strength. Now we can have a fight between these two and this one will win because it has more energy. So we will have 2 and 9 as the remaining energy. So you see, based on we decide how the fighting happens, we can have 2 as a winner. We can also have 3 as a winner. And you can probably see like array symmetrical, so we would also be able to have 4 as a winner as well. And problem says, look at the complete array. You have a choice how the fighting should happen. Now give me the count of all the fishes that can be winner here. So in this case, the answer was 3. Any questions on the problem statement now? Like a lot of definition is there, but we can briefly summarize the problem statement like this. You have a long array. You look at adjacent two element. You see which one is larger. If they are equal, you have a choice to decide which one is larger. And kind of like you have n different fishes. Each of them has different strength or weight. Let's just say weight. Now you can choose 2 fish which are near to each other. You have a fight between them. The one which has a larger fish wins the match, and that fish eats the smaller fish. So the new weight would be sum of original fishes in the fighting. And if you see, like once you have a lot of fighting, at last you would have only one fish remaining, whose weight would be equal to sum of all the elements. And problem statement asks us to say like what all indexes can be the final winner there. So any questions on the problem statement? Okay, to jump onto the solution, my idea was DP. Let's say we have a solve function. And let's say we have one fish with weight equal to L to R. Like, and question is, can this fish be the final winner? The problem is, we have a solve function which takes an index L to R, which basically means we have one fish with weight AL plus up to AR, and can this be the final winner? And like only this fish has some fighting with some people. Like we did not have any fight with any two fishes. So my idea was we have A1, A2 up to AL minus 1. We have one fish with has some AL to AR, and then we have fishes of weight again AR plus 1 up to AL. The idea is using prefix sum. We can binary search like what is the maximum weight up to which this fish can fight here. Like assuming like this weight is let's say 100, this weight is 90, 5, 10. Then we definitely know the all the fishes with sum less than equal to 100, as long as we go to the right hand, sum of all the indexes less than equal to 100, this can definitely fight them and win against them. So like I do a binary search here I would get R plus 2. So I say like this fit fought with some of its neighbors, and now it has got the weight of L up to R plus 2. So new solve can be a fish of weight L to R plus 2 can win the complete match. I can either move right or I can even move left. So I can binary search even on the like prefix sum up to which I can find. Let's say this index is 80, this is 15, this is 2, this is 100, and this is weight was 100. So we can even jump on 3 index here up to L minus 3, and we can also call solve L minus 3 comma R. Because if this weight is 100, if we took some segment of fishes over here with total weight less than 100, less than equal to 100, this can definitely win against them. And like this was the idea I had. Like you have some L to R, find max index to right using total weight, max L, and just move left pointer to that or right pointer to that, and can you win against them? And like a DP on the top of that, like DP you can maintain it in a map which says like if you are answered for L to R, store this answer somewhere. So next time someone asks you to find an answer, you don't have to again find the right boundary, left boundary records again. For every index you can get in L2R, it looks like it should be order n square, but in practice it turned out to be faster. So to check if jth index can be a winner, I call solve j to j. Like basically I have a fish which has weight equal to from index j to j. Can this index fish be a final winner? Now for this fish index j, I look at what is the maximum weight up to which it can eat in one go. Then on the left side also it can eat in one go and keep doing that. And that was the idea for E1. At least I don't have a proof on time complexity for this, like why it would get and what is the number of states there, but that was something which worked here. So I am maintaining this DP vector map. This is a pair which takes index L and R, and Boolean maintains can this fish be a final winner on. So now I have this recursive function which takes index L to R. So in DP vector I am maintaining this pair as a key, and if I have already know the answer, like I have computed this answer from L to R somewhere, then directly return it. If my L is 1 and R is n, this is complete subarray. So if one fish with total weight equal to all the fishes, then this can definitely be a winner. So return true there. Otherwise, I am maintaining the prefix sum array. So what is sum of elements from L to R? This would be sum of elements from L to R. The next element, if I keep moving to the right, in one go, like how many fishes I can take with, like such that sum of that segment is less than my current sum, which I can find using upper bound, like like 1 second. The idea would be next are up to which I can go. Its prefix sum would be this. So I want this to be less than equal to sum. So this means find maximum index r, which is less than equal to pref r plus sum. So the idea was to use upper bound lower bound function over there. Upper bound will give me element with sum just greater than that. So I need the element less than that. If this increases my right boundary, then directly now solve for L2 next boundary and store it as an answer like. If up to next boundary can be the complete fish, then L2R will also be a fish. Otherwise, I can definitely not move to the right because the fish on the right has weight more than my current weight profile. So the same thing for the left part. Find the maximum index L such that sum is less than equal to sum. So like I want I is less than equal to my current sum. So like sum of I up to this would be this. So like this, if you move around, this equation would be like this. Like prefix sum I should be less than equal to this. So lower bound on prefix sum this, and like I need, because it was I plus 1, on prefix sum it would be I plus 1. So if I cannot even, if this next L is equal to L, which basically means L2R is my current fish. The fish just on the right and fish just on the left have weight more than my current weight. So I can never be a winner. Return false. Otherwise, solve for by moving the left pointer here. And for all j equal to 112, check if we start from only one fish of weight j, can it be a winner, answer plus plus and print that answer. So this was the solution for E1 IR. Like I definitely don't have a upper bound on what would be the time complexity for this tool. This definitely looks like order n square, but definitely not an order n square solution. And like my time complexity was also a bit worse here. So around takes which 1.18 second. So any questions on problem E1 before we jump on to E2? Okay, the idea for E2 was a modification on this part only. We need two helper things here. The problem statement says, instead of taking the complete array 1 up to n, I will give you some prefix of the array a1 up to ax, or let's say some aj. Count number of winners in this part. And like you have to print this for find this for every j equal to 1 to n. Just to prove it, they just said x, but x does not make much sense. Find this for every j equal to 112. If we know for every j equal to 112, we can also print for j equal to x12. So my idea was, I did two things. Let's say if I have a fist of weight 1 to j, what is the maximum weight subarray I can get by just hitting one neighbor after the other? Pre-calculate this. We can definitely pre-calculate it. If I want to look at one, if I know answer, like what is the maximum weight up to which I can eat by taking a fish of weight 1 to j plus 1, then for 1 to j, if sum of a1 up to aj is greater than equal to aj plus 1, then the answer is same as now this fish can eat this one as well, and you can use the answer from j plus 1. Otherwise you cannot move right, so the maximum you can get would be index j only. That was one pre-calculation I did here. What is the maximum fish up to which you can eat? If you start at index I, you can definitely go up to index I. If you basically means if you have fish of weight from 1 to n, you can definitely eat everything. Now for all j equal to 1 to n, if sum of first j element is greater than equal to the j plus 1th element, then you can eat the right neighbor and you can go as long as right neighbor can go. Otherwise you cannot go up to right one. That was one thing I pre-calculated. Next thing I did was to reuse previous solve. Where the idea is instead of returning true and false, I will say if I start from L to R, what is the maximum index up to which I can go, so that I can take some complete prefix. Let's say this is L to R. My idea would be to always jump left. Sometimes I may have to even jump. Now, like let's say I have a sum like this. Now I cannot eat the left one, so I will probably make some jumps on right too. And at last, like I will always prioritize going to left rather than right. And at last, I would get a prefix like this, where I can eat everything from 1 to some index. So basically for given L to R, find it can become a prefix or not. And if it can become prefix, what is that minimum index you can get for the prefix? This will definitely be greater than R. So like basically keep fighting, try to fight with the left neighbor. If you can't, then go to some right. And the idea is for this segment, I will try to get the maximum I can get as the prefix first. And the idea is because once I know this side, then I know like for every element which takes from, for every x, like basically for every prefix with min length, because I know like once I have fixed what is up to maximum I can also go. So for every length I to max R, this L to R can be the, like L to R fish I had can be the final winner. And like this was the idea. Just that earlier from L to R, we were jumping to the maximum possible we had. That was one jump. But we can now also try to look at this AL minus 1 and try to jump such that this way it becomes AL minus 1. And like this would be the idea for this problem, E2. One pre-calculated, if I have a fish for of weight from 1 to A1 to AJ, what is the maximum up to which I can go by eating right neighbors? This solve function L again, which takes L to R. Earlier it was Boolean, now it's an index. If I have pre-calculated for L to R, just print L to R. If my left neighbor is 1, then whatever the right index I have, I definitely can get out, like that would be the minimum possible I can get over here. So just pre-calculate, return it. Look at current sum. Try to jump on the left side. If I can eat something on left, just jump onto the left and try to find the answer for the left part here and it again. If I cannot jump to the left, then look at what is the weight of fish at index L minus 1. This would definitely be more than my current fish weight. Otherwise, I would have been able to jump here. Now to get a total fish weight more than like previous weight, like not this as minus 1. Try to find what should be the boundary we should increase so that we can get weight L minus 1. That would be some boundary. And there would be one more boundary up to which I can fight over here. So find those two borders. If I want to take L, then my total weight should be more than previous value I have just before it. And that would be like, this would be the value in prefix sum I need for taking it. And the maximum I could take would be like prefix sum R plus some the earlier jump I was doing, which would be upper bound over here. So if I am able to find like, so the minimum index up to which I will have to keep eating so that I can eat the element just before it is less than what I can directly eat, then just go to that left part only. Otherwise, like if you can go to some, now if you cannot eat to the left part, does not matter how long you can go, then just go to the maximum weight up to which you can get and try to find the max index. Otherwise, like you can either eat something on right, you can either eat something on left. So you can never be the final winner of some prefix over here. The same story goes for each index. You say like I have a fish with weight J, like can it be a final winner, or if it can be some prefix winner, what is the maximum length of that prefix? That is what I am calculating with this function over here. If it returns minus 1, this fish can never be a winner in any of the prefixes. Otherwise, I find like if I start with that prefix, what with is the maximum run up to which I can get. So like this would be the maximum winner up to which I can get. So like fish J can be a winner. For every prefix with length between min ideas and max ideas. Now, like for each which you can calculate a range up to which it can be a winner. Now, to get for all the ranges, you can either do a segment tree, add something on a range, or I try to do it with a range minimum array like this. So basically, difference array or number of like when you look at prefix for min index, the count increases by 1, and when you look at index for max prefix 1, like the fish J can no longer be a winner, so that count decreases by 1. Now a prefix sum on that and return print all the values for the given x2 or 2, and like that was my solution for EP. Again, like I don't really have a proof for time complexity. It was more of proof by AC, and like that was my solution for EP. So any questions on any problem? Like probably I haven't really spent much time on D, so like I don't really have a solution for it. And I think I was able to explain all of them apart from D. So any questions related to this contest or any other thing before we start? If thanks everyone who for joining today. Like how to keep on practicing. There are two parts to it. One, you are looking for some motivation. One, you want to practice but you don't know what to do. So I can answer with the second question, like you are motivated enough to do something, but you don't know what to do. Then for that, you can probably look at roadmap to read in 2 minutes, a clickbait channel on my Discord server, where I have some advice on how people should practice or how I used to practice. Like there are some advices like you should do ABC if you are looking on some standard topic, this is what you should do. What I did when I was expert or below, what I did when I was targeting 2100 rating, and as TLDR is to get better X 2X. So if you want to get better something, keep doing it. And if your question is how to find a motivation to do it, my advice is just stop. Like don't look out for motivation there. Like you can probably do something better there. Because motivation is something people can't just bring in you. I am stuck between able to solve a problem, I have no idea what to do. Like it will probably come with some practice, I would say. Yeah, like one thing which I advise people is probably not look at problem rating there. So you don't know what you are doing. No, like I think the Discord list definitely works. I can probably take a look at the Discord mentioned in the server. No, I don't really have a bot. Like probably if you have suggestion on how to set up a bot which says iPhone, Discord, etc., then I can set it up. Like you can just ping me on Discord server how to set up a YouTube bot. And next time, call and Discord with you. Not working for me. Like I don't know. Like probably this is the link. Or probably like it may happen like probably your account was hacked and like you spam the server. Then like generally I do ban the spam account. So that may be the reason, but then you can reach out to me for an updated invite or probably just to report on. Unless you are involved in some cheating, like I generally don't ban people. Sometimes I just pick or ban people when their account has been hacked, and I can remove that ban if you have been banned due to spamming, not due to some cheating. And that's it. So thanks everyone for joining today, and yeah, like, I think I had an overflow bug which I could not figure out until I was trying to explain it. Otherwise, I would have had an AC on C and even an E2 was a nice one. And so thanks a lot. I think I will end my stream now.